So depth, hold on, real quick. I do want to go back real quick. Just so I want to put this relationship on the board real quick. So these two sonographer control settings, so I'm going to add to our list, guys. I'm going to draw a line right here to separate them, but everything is still going to be related to frame rate, okay? I'm relating everything to frame rate on this thing right here. So our imaging depth, so I'm just going to put depth and the number of pulses, because we're going to find out there's 3 ways we can change the number of pulses per image. We're going to find that out real soon. But the number of pulses, they're both inversely related to frame rate. I'm telling you right now. They're both inversely related to frame rate. Remember, just think of it real quick. If I have to go deeper into the body, I'm increasing the depth. It's going to take me a lot longer to get these. It's going to decrease my frame rate because it's taking a lot longer to acquire these images now, right? Because the sound has to travel so far to get there and come back. Okay, so I will say this real quick: imaging depth and the number of pulses in each picture are inversely related to frame rate. Remember, I'm relating everything to frame rate. Okay, so I'm going to draw my arrows down right here. I like summarizing stuff up like this. Just like I said, understanding those relationships. Understanding those relationships. Probably after I get through the lecture, you guys read it a second time, it'll come real quick. Okay, so let's talk about imaging depth. So depth and frame rate, like I just told you guys, are inversely related. Shallow images increases frame rate and improves temporal resolution. Why? Because shallow images, if my frame rate increases, of course my temporal resolution is going to increase too, right? Because they have a direct relationship. Okay. But if I have to just go into a shallow depth, then my sound is able to travel, and the rate I'm creating frames is able to be faster because my sound doesn't have to travel as fast. Remember, we assume that ultrasound, it sends out a pulse, and then it listens for that pulse, the reflections to come back before it sends out another pulse. So if I have a shallow distance, then it's going to be able to send out more, right? I can even add to this list. Can I add PRP and PRF on this list as well? Yep. Right? Because if I'm talking about going return time, I'm talking about the PRP, right?
Yep.
I'm talking about PRP. And I'm talking about the number of pulses being sent out per second. Then I'm talking about PRF. I can add those to this list if I wanted to. Okay? I'll probably add them later. Okay? So with shallow images such as this right here, we're going to get increased temporal resolution because the sound is going to be able to go back and go to and back really fast. Okay? With deeper imaging, we're going to decrease our frame rate because it's going to degrade temporal resolution because now sound, it takes longer to travel deeper distances and travel back. Therefore, our images are not going to be acquired as fast. Okay? The T frame is going to be a lot higher, right? The time it takes for one image to be created is going to be a lot higher.
Could travel longer.
Exactly. Okay? So, depth and T frame are directly related.
Yeah, definitely, yeah.
Depth and T frame are directly related, right? So I don't even care if you got to get on a test and you got to make this little thing right here. Remember I told you to do that with PRP, PRF, duty factor, and depth. Remember I told you to do that on the second and third test?
Yeah.
Same thing.
Every test.
Every test. Know those relationships, guys. I don't care what number I throw out there. I don't care what number. Yeah, what number, like if I make it a problem, if I make it a math problem, that don't matter. It's all about you understand. So depth and T-frame, depth and the time it takes to make one image are directly related. If I travel deeper, if I'm increasing my depth, the time it takes to make one image is going to increase as well. Because now my pulses have to travel further to and back to the transducer to create this one image. Okay, so this brings us to our problem, guys. So we can figure out what the T-frame is. We can figure out how long does it take to create one image. I'm just going to keep saying the definition of T-frame. We can figure out how long it takes to create one image. Okay, that formula is when we take the number of pulses, if I know how many pulses are going to create this one image, and I know the go and return time, if I know the PRP, right? Because isn't that what the PRP is? PRP is one on time, one off time. If the time it takes from the beginning of one pulse to the beginning of the next pulse, right?
Mm-hmm.
What is just the on time? What is that? It's the talking time. What parameter is it? What pulse parameter is that? Just the talking time. And I'm just quizzing.
For duration.
Pulse duration. Pulse duration. I'm just quizzing. It had nothing to do with this. I'm just making sure we don't lose it. Because remember, I told you it's a foundation. We can't forget it. We have to keep building on it. Okay. So the number of pulses times the go and return time will give us the time it takes to create one image, right? We all understand that?
Mm-hmm.
We're good? We're good, guys? Okay. So we got a little problem we can work out. Alright? So in this example, straight out the book. Assume that an image is created with 100 distinct pulses. Okay? Each pulse travels a maximum depth that requires a round trip time of 1/1000. Round trip meaning one go, one return, one talking, one listening, one on, one off. Right? So it requires a round trip time of 1/1000 of a second. Okay? Our T-frame, to figure that out, here's our formula right there, guys. Number of pulses times the PRP. We have both of those numbers. Number of pulses times 1/1000 of a second equals 1/10 of a second. Okay? What is our frame rate?
0.1.
What is our frame rate?
10. It's the opposite.
Frame rate is going to be 10 hertz.
10.
Frame rate is going to be 10 hertz. Remember, when they're reciprocals, if it's a whole number, all you gotta do is throw one on top of it, right? If it's a fraction, all you gotta do is take the denominator. Okay, when it's a reciprocal relationship. Okay, so let's look at the second one. We're good on that first example, guys?
Yep.
Sophie, we're good? Okay. So now imagine the technology adjusts the depth to half as deep, and the time of flight will be 0.5 or a half or 0.5 thousandths of a second. Okay. The image still requires. You see how I changed the verbiage on you guys? I'm saying the same thing as the first one, right? If I'm saying time of flight, isn't that the same thing as round trip time? So don't let the verbiage fool you either. Okay. The image still requires 100 pulses. Okay. So now we're acquiring images in a shorter amount of time, right? Because this number is smaller. We're acquiring images in a shorter amount of time. That means we're acquiring images a lot faster now, right? Because it takes less time to acquire this image. Instead of it taking 1/1000 of a second, it takes 0.5/1000 of a second. Okay. I don't know the correct way to say that, honestly. So to figure out our T-frame is going to be the number of pulses times the go and return time. Okay, so our number of pulses hasn't changed. 100 pulses times 5/1000 of a second. There it is, right there. That's going to give us 0.05 seconds, 5/100ths of a second, or 1/20th of a second. Right? What is our frame rate?
20 hertz.
20 hertz. 20 hertz. Are we going to have with 20 hertz? Example 1, is that going to have better temporal resolution, or example 2 is going to have better temporal resolution?
2.
Example 2 is going to have better temporal resolution. Okay. Same thing, just like with axial resolution, we like the high numbers, right? Like the high numbers, right? That's going to provide us with better temporal resolution. What's wrong, finance?
Is it the lower numerical value?
No, rim rate.
No,
Oh, I'm tripping. You're right. On axial resolution, it's a lower numerical value. Just the opposite then. Okay. So 20 hertz is gonna be better than 10 hertz when we're concerned with resolution. Okay. I don't know if I'm gonna give you any, problems like that on there, but it may be depending on if it's like a word problem. Now you may have to figure out what the frame rate is or what's the T frame. Right. So when we talk about shallow imaging, guys, concerning imaging depth, that's going to be a short go and return time. right? Shallow imaging meaning that we're listening. Remember, when we're changing imaging depth, only thing we're changing is listening time, right?
Mhm.
Remember, the pulse duration is already established. We can't change that. We don't. That's not a sonographer control factor, right? The pulse duration is already determined by the manufacturer. Okay? We only change the listening time. Okay? So if we have a short go and return time, like a thyroid, then we're gonna boom boom. It's superficial. We're gonna boom boom come back. Okay? Our PRP is gonna be short. Okay? So just like that means that my PRF is gonna be high, right? Because I'm able to send a lot more pulses in the body per second now. Okay, remember I said I can add that to that if I wanted to. Okay? So we're also gonna have a shorter T-frame, right? Because it's gonna take less time to create that one image. Okay? We're gonna have a higher frame rates. T-frame and frame rate are inversely related. Okay? Like I said, you can just, like I may even have a table where it says which one of these do not belong. And I have short T-frame, high frame rate, inferior temporal resolution. You know, that you'll know the one that doesn't belong is inferior temporal resolution, right? So, you know, just know how everything is related to each other. Okay? With deeper imaging, we're gonna of course have a longer PRP, okay? A short PRF, a low PRF, right? We're not able to send pulses as often. Okay? A longer T-frame is gonna take a longer time to create that one image now. Okay? With that being said, it's taking a longer time to create that one image. We're also gonna have lower frame rates because of that. Okay? Because it takes a longer time to create that one image, we're also gonna not be able to acquire our frame rate isn't gonna be as high. Okay? And we're gonna have inferior temporal resolution because of that fact we're not acquiring images as fast.
Mhm.
We're not acquiring images as fast. And these are the same tables that are in your book, guys. Every time you see a table, it's the same table that's in your book. Okay? Okay. Any questions on imaging depth in relationship to frame rate? Inversely related, right? Inversely related. Imaging depth is inversely related to frame rates.
Mhm.
Okay? If I have shallow imaging, right? If I have shallow imaging or a short go and return time, then my frame rates are gonna be high. I'm able to acquire a lot of images per second. So that's what frame rate is. The number of images we can acquire per second. Okay? Yes, ma'am.
What it means that, can you just explain so superior temporal resolution, what is it mean?
Superior is gonna be optimal, it's gonna be the best, it's gonna be better. Superior means better. It's gonna be good temporal
Like
resolution.
heaven,
Versus inferior meaning bad.
hell.
Huh?
It's like heaven and hell.
There you go, dude. Okay. Any questions on imaging depth, guys?
Say that again about something being inversely related.
Inversely related?
You just said something before.
I think I said T-frame and frame rate are inversely related. T-frame and frame rate. Remember that's that special relationship. They have a reciprocal relationship. Okay. If you guys read my little handout, man, it's real quick hitting
A little bit.
facts. Real quick hitting facts. Make sure y'all check that out over the weekend when you do your homework. Any other questions before I get into the number of pulses? Remember I said it's 2 sonographer controlled settings. One,
Imaging depth.
imaging depth. The second one is going to be the number of pulses per image. Okay. There are 3 ways to change the number of pulses per image that was given an example in this book. Okay. 3 ways to change that. You already know one of them already because we've been talking about it for a while. Okay. So remember I said both of our sonographer control settings, they're both inversely related to frame rate, right?
Mhm.
They're both inversely related to frame rate. Okay? So pulses per frame and frame rate are inversely related. If I have more pulses per frame, if I have to make more information, send out more information per image, then I'm not going to have
Decrease.
great frame rates. Okay? Because it's going to take a longer amount of time to create those images each second. Okay? Frame rates are higher when each image contains fewer pulses. Okay? Frame rates are lower when each image is made up of more pulses. I think I sent you the PowerPoint I sent you. It's this exact same PowerPoint. I just remember I told you I'm making all of them look uniform. All my PowerPoint look the same now. So you just got my last year's version, but I think it should be exactly the same, or little differences.